It's not needed, sir, but I'll invite you, sir. Yes, we are live, sir. ओके, नमस्कार सभी दर्शकों को जो हमारे साथ इस समय राष्ट्रीय विज्ञान दिवस नेशनल साइंस डे के शुभ उपलक्ष्य पर हमारे साथ हमारी ऑनलाइन यूट्यूब चैनल पर जुड़े हुए हैं। एक बार आप सभी को आंचलिक विज्ञान केंद्र भोपाल, रीजनल साइंस सेंटर भोपाल की तरफ से सुप्रभात और राष्ट्रीय विज्ञान दिवस की ढेर सारी शुभकामनाएं। हर वर्ष की भांति इस वर्ष भी आंचलिक विज्ञान केंद्र भोपाल राष्ट्रीय विज्ञान दिवस का आयोजन कर रहा है एवं इस साल हम नेशनल काउंसिल फॉर साइंस एंड टेक्नोलॉजी कम्युनिकेशन, डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी न्यू दिल्ली एंड एमपी काउंसिल ऑफ साइंस एंड टेक्नोलॉजी के कैटालिटिक सपोर्ट के साथ इस वीक लॉन्ग सेलिब्रेशन को मना रहे हैं। इस उपलक्ष्य पर आज हमारे साथ है प्रोफेसर हुसैन जीवाखान।
सॉरी टू इंटरप्ट, स्वप्निल, देयर इज एन इको इन द line background. I think there is a second channel which is working.
Yeah, sorry for the interjection. So आज इसी उपलक्ष्य में हम एक लेक्चर ऑर्गेनाइज कर रहे हैं।
अभी भी इको बंद नहीं हुआ है। जीवा खान सर, आपका क्या दूसरा वॉल्यूम ऑन है क्या?
नहीं, बंद है सर मेरे।
आपके दूसरे
सिस्टम का वॉल्यूम बंद है सर।
हेलो,
हाँ सर, मेरी आवाज आ पा रही है?
या इट्स फाइन, यस सर। सो इसी उपलक्ष्य में
सर इनकी आवाज नहीं आ रही है, माइक ऑफ है।
इसी उपलक्ष्य में आज हम लोग एक पॉपुलर साइंस लेक्चर का आयोजन कर रहे हैं जिसका नाम है।
सर आपकी आवाज नहीं आ रही है।
पॉपुलर साइंस लेक्चर का आयोजन कर रहे हैं जिसका नाम है, जिसका टॉपिक है, हमारे साथ प्रोफेसर जीवा खान सर जुड़ चुके हैं। सो मैं विदाउट टेकिंग मच ऑफ योर टाइम मैं चौधरी सर से रिक्वेस्ट करूंगा कि वो हमारे आज के स्पीकर जीवा खान सर को इनवाइट करें और इस प्रोग्राम के ब्रीफ इंट्रोडक्शन दें और इस लेक्चर जिसका नाम है इनोवेटिव मेथड्स और फॉर लर्निंग साइंस को हम शुभारंभ करें। ओवर टू यू चौधरी सर, प्लीज।
Very good morning to all the viewers of our channel. Regional Science Center Bhopal does a lot of activities throughout the year which are planned for promotion of science and to grow general awareness among the public in Madhya Pradesh, Bhopal. This time on 20th of February we are celebrating National Science Day, and this program we conduct every year on this particular day to celebrate or to mark the achievement of Indian scientist Sir C.V. Raman, who actually brought us Nobel Prize in the year 1930 in the field of physics. He is the first scientist in Asia to bring Nobel Prize in the field of science. And this year-long program which we are doing this time is being supported by NCSTSC and Madhya Pradesh Council of Science and Technology. And as we are in program where we are trying to provide a lecture through one of our professor from NITTTR on the theme Science, Technology and Innovation. As we understand that science is essential and technology is also required for bringing innovative systems or products which can help society to progress and move toward the future. Without taking much of time, I will request Professor Jeevakhan, who is in Department of Physics in NITTTR Bhopal, to continue with his lecture.
Okay, very good morning to all of you. Am I audible?
Yes, sir. Yes, sir. You may continue. Yes.
Okay, so I'm a very good morning to all the viewers. Myself, Dr. Hussain Jeevakhan, and I'm working as assistant professor in Department of Applied Science and Education, NITTTR Bhopal. And I'm a person of physics, and I thanks the organizer for inviting me for this National Science Day and be a part of it. So I'll just start my session. I'm just sharing my screen. Okay, is my screen is visible to all of you?
Yes, sir. Yes, sir.
Sir, is my screen is visible?
Yes, sir. Your screen is visible. You may continue, sir.
Okay, fine. So for the today's National Science Day organization from the Regional Science Center Bhopal, the topic of my talk will be innovative methods for learning science. So, and due to present scenario, I think all of us are involved, dependent on the online teaching and online teaching resources or online learning resources. So that's why I have taken these as a theme for today's session, so that we can learn science even due to all this situation. The learning outcome for this session will be use innovative learning methods for science, and then we'll identify the various online open education resources for science education. So these will be the learning outcome for this session. Now, before moving ahead, we'll just see that what are the content we'll cover. So first of all, we'll see teaching methods, which is simulation, then use of open education resources. They are also known as OERs. Then we can also use mobile application. We can also use augmented reality apps in a limited way. And then the last thing which I just want to share is the tracker software. So how you can design an experiment with the help of tracker software. So these all topics I will try to cover in this session. Now, first of all, simulation. So what is simulation? Simulation is everything. Whenever we have a real experiments, we know that learning by doing. So whenever we do something, we learn a lot. So the same thing goes with the lab. Whenever we do some experiments, whenever we do hands-on experience, so we get a real learning. So this is true. But whenever we don't have an opportunity to do that learning by doing, or we can't do hands-on experience. Right now in the present situation, we can't go to schools, and right now we have started, but there was some time that we are not able to go to the schools or colleges, and we are not able to do the experiments. So still we can do this experiment with the help of simulation. Okay. And simulation is an operating representation of a real system or a process. So whenever we are having a real process, if we do its operating representation in general in a computer system, or maybe in some mechanical system also, so we call it that we are not working on a real system, but on its simulated part. What is a good simulation? If it is very good to a real apparatus. So if we design a simulation, maybe in a computer or maybe in mechanical, so whatever the errors or whatever the real experiences we are getting in a real system, if the same thing we are getting in a simulated environment also, so that is also a very good simulation. So those person who are involved in designing the simulation through computers or maybe through some other devices, so what they do, take care that the simulation which they have designed, so it should be very much real to the it should be very much near to the real one. And in simulation, although we are not working in a real system, so we are working in a computer system. So there is no danger that we can damage the equipment. And the other thing, the beautiful things with the simulation we have, which I think that we can do a variation of number of parameters, which in a real system we are constrained. We can't do much of change in the parameters. The things which appeal for me in simulation is that I can do a variation of parameters in simulation. So these are some of the advantages of the using simulation as a method. And why we are going for simulation, why we are going for simulation, and why the young scientists or the students, maybe of school, maybe of college level, why they should learn simulation. As we all know that the whatever real experiments we do, suppose we do mission of Mars, we do LHC, Large Hadron Collider. So these experiments, they are very costly, and lots of public fund is involved in it. So we can't use this experiment on trial basis. So before doing the actual experiments, we want to study a lot that what can happen whenever these actual experiment can take place. So these all we do with the help of simulation. So we do simulation, and whenever we are getting the right result with the simulation, then and then we go for the actual experiments. So according to me, and it's a need of time that a student should know that what are the simulation software available in their branch, maybe in science, maybe in engineering, maybe in technology. They should be aware of some of the simulation tools, and whatever the work they are doing, so they should be aware and they should be skilled to work on 2 or 3 simulation software. So with this session, I just try to convey this message to all of you, that just try working on the simulation and try to explore yourself that on which simulation software you can work in your branch. And in simulation, whenever we do simulation, so we always talk that whenever we learn something, so there should be an active participation. So simulation, it has a scope, it's an ample scope that it can involve the active participation of learners, and learners, they're able to take decisions. So these are some of the important skills which requires whenever we learn new things, whenever we want to explore something. Okay, now why we want simulation? So I will go with a quotation from Lord Kelvin, who has given the absolute scale of temperature. And according to him, when you can measure something, what you are speaking about, so you can say that you something new about it. Because at his time, the people they are working, they are talking about the Maxwell theory of electromagnetic radiation. They are talking about the velocity of lights and how the EM radiations are all about. And parallelly, there was an experiment also going on that they have all the scientists, they worked out they have measured the velocity of light. So if you don't measure it unless that hypothesis or that theory cannot be that cannot be proved on. So similarly, right now, nowadays we can say that we can paraphrase his statement, his quotation, and we can say that when you can simulate what you are speaking about, and you can present it visually, so you can say that you know something about it. So even in maths, because maths is a very abstract subject, but right now the mathematician, they also tried, the maths teacher, they also tried to show what equation they are talking all about. So that's why we can say that that's why simulation is very much important. And I just want to share one of the important experience which a student has taken when he met CV Raman, and he asked that, sir, I want to do research with you. And then CV Raman asked him a simple question: okay, just go and find out the volume of this flask, some material he has given, and just try to find out the volume of it. And within a few minutes, that student go and come out with some results. So then CV Raman has asked that, okay, you can't work with me. So he asked the question, sir, but the volume which I find is good. It's almost near to the actual volume. So then Professor CV Raman replied that, okay, you have find the volume, but you find the volume only with one method. But the person who do research, I think they should explore the number of ways that how that volume can be measured. So similarly, what my submission to all of you, just try to explore that if I learn the things with this method, suppose by project or by experiment, then why can't with simulation? Why can't by some other method? So we should also explore the number of methods with which we can learn a concept. So that concept will be reinforced, and it will bring a lots of questions to our mind. So with this suggestion, I just start my I just go with my further presentation. Now, open source simulation tools. Right now, there are lots of, because in last 1 year, every one of us, we are educated a lot using the online tools. Because we haven't thought about before 1 year that we will learn all these things, but within 1 year we have learned lots of things. So these are some of the suggestive open source simulation tools which as a student, as a teacher, you can use for your learning physics, chemistry, maths. Okay, so these are the sources, these sources are PhET, vlab.co.in, Geogebra, OLabs, tracker software, and there is one website which is PhET, free and open source software for education. So you can explore all these websites, and after this session, please try to work on it, and maybe you can find that whatever concept you are learning, maybe by book, maybe some other method, with the help of simulation also you can learn that concept. Okay. So the first simulation tools or the open education resources which I will just want to share with you is PhET simulation. This PhET simulation is founded in 2002 by Nobel laureate Carl Windman. And this PhET interactive simulation project was started with the collaboration of University of Colorado Boulders, and they have created free interactive maths, science simulation, based on extensive education, and engage students through an intuitive game-like environment where students learn through exploration and discovery. Okay, so these are all the aims with which this has been developed. Sir, am I still audible to all of you? Okay. Okay, please tell me in between if there is some discontinuity. Okay. Okay, fine. Thank you very much. Thank you for the feedback. Now, this PhET simulation, if you go to your Chrome and or if you go to Google and you just type PhET, so you will directly land to this website PhET simulation. I also hope that most of you are already working on it. So let us see demonstration of one of the PhET simulation which is available on this website, and this is on the basis of Ohm's law, and Ohm's law is very common topic, so that's why taken this topic. So this simulation gives us the visualization of Ohm's law. Okay. Now in this simulation, there are three types of simulations available in this. One is in HTML, one is in Flash, and one is in Java. When you visit this website, so you will find these three software, and the HTML is very user friendly. You don't require any software, you just require an internet connection and you can start working on it. And this type of simulation you can also download, and you can also work on it even you are offline also. So there is lots of flexibility available for such type of simulation, and there are lots of simulation available in physics, chemistry, maths, even in the other branches of science also available simulation. So just try to explore this PhET simulation. So I'm just going to demonstrate you that how you can visualize the Ohm's law. Okay. So with this, in this, there's a simple relation V equal to IR has been written. And if you change the voltage, okay, if you can change the voltage, you can see that the figure of this letter V also increases, and this battery also increases. When I increases the resistance, so you can see that there is a decrease in the current. So two parameters we can change. One, we can change the voltage, we can change the resistance. Again I will play this video. Okay, so in this, when I'm changing the V, so this battery will also change. Or you can see the battery. This battery is also changing, and the current is also increasing, and letter I is also increasing. And when you increase the resistance, so the current is decreasing, and when you decrease the resistance, the current is increasing. So you can qualitatively and quantitatively figure out. And similarly, when you visualize, one thing I think you have noticed, that when I'm increasing the resistance, so the number of obstacles, number of the ions which creates the hurdles in the path of the electron, so they are also increasing and decreasing. So it's also visualize us the specific resistance of the material. So that also we are able to visualize with this simulation. So this is a simplest simulation we are having. There are lots of simulation available in PhET. Okay, the other simulation is from chemistry, which I've taken for the demonstration of this session. And in this, the concept of concentration has been explained. So we are having this volume half liter. We are seeing, we know there's no, we have added nothing. Now we are adding something. So it will increasing the, if it is increasing the concentration, so we are increasing the solute, we are increasing the solvent. So the concentration of the solution is changing. We can also change the way we, instead of powder, we can have a liquid solute. We can change the amount of the solvent, and the effect of the change in the concentration of a solution, how it depends upon the solute and how it depends upon the solvent, that also we can visualize the student. So the aim of this, all this interactive simulation, first of all, there is a research team working in this PhET simulation. And in the PhET simulation, they have taken care of that, how they can make it more attractive. So they have done all these things. Feedback from the student, feedback from the teachers have been taken, so that they can redesign, or they can change their simulation in more effective way. And when you visit this website, PhET simulation, you will see that lots of content is available for the student, for the teacher also. And as a teacher also, from this simulation, you can design your own activity. And if you want that, okay, I can design an experiment, I can design a learning material, or maybe you can use as an online teaching ad, and you can work out, you can frame your own activity for a student. You can give your student a link, and the student will follow the instruction which you have given in your activity sheet. So that's why this experience will be a learning experience only after that. So lots of teaching community, they have shared their experience, and as a teacher you can also use this material, and you can also share your material with your name in this website. So that will be a very great help to all the people who are working for the one single reason, that is learning science. How to make learning science effective to the students as well as to the teachers. So and when you visit this website, I'm sharing my personal experience. When I visit this website, whatever I'm thinking, I found that lots of the teachers, they think in the same way. So you also have same experience when you visit this website. So this is the one I have shown is of physics. The other one is these I have shown of the chemistry. Some basic, I have taken the simulation. And this is the link. You have to share the link with the student. The student will go directly to this link and then start working on these simulations. Okay. And now it's not that only the physics and chemistry simulations are available. Even for grade some smaller grade students also, there are maths application available. You can also teach. You also take the help of those simulation. So you can see the simulation with the help of grade level. Okay. That maybe of school, maybe of college simulation, what type of simulation you are looking about. Okay, you have to sign in whenever you go to this website. You have to sign in, maybe from your Google credentials, or maybe you can register. You can create your own new credentials. So most of the nowadays most of the open source educational resources, you can sign in with your Google credential and you can start working on it. Okay, and there are simulation available for the complicated, for the projectile motion also available, and even for the Fourier transform. So from the simple to very complicated concepts of physics simulations are available. Okay. So these are the simulation available for mathematics, and for mathematics, as earlier said, now visualization is very, they started working on the visualization. So these are all the simulation available with the mathematics. And one simulation I just want to share, which is the graphing lines. So whenever we see this concept in the book, so lots of very less figure are available, but we can play with it. We can play with the simulation, because as a game like environment will be created, so we can change lots of parameters we can vary in it. Okay, so this is a line equation is given here, with y equal to mx plus c, where slope is 2/3 and intercept is 1. We can change it, we can increase this intercept, we can change the slope, and with the change in slope we can see that how this line will change. Okay, so I'll just try to demonstrate this with you. In this okay, in this we have changed the slope. Now the slope is 1, okay, 3/3, okay, and the intercept is 5. So if it is intercept is 5, so it will positive 5, so it will cut on this, okay, and this is our slope, okay, and okay, it will cut it -5. So something we can visualize this line, y equal to x plus, this is y equal to x plus 5, okay. This equation 3/3 is 1, so y equal to x plus 5. We can see that what is the slope and what is the intercept. Okay, intercept on the x-axis where it cuts. Then we have we can have a game also. We have a game also. And in this, the student can play a game. They can test their knowledge also. That this software will give you that find out the slope of the line, and then they have to find out the slope of the line. So you can use the simulation for your for learning also and for your assessment also. So both way you can use some simulation where some these quizzes and all these are given in the simulation. Okay. Now the next simulation is one of the with graphing line. There's a simulation for the quadratics also, for curves also. So this is graphing quadratics, and in this you are having a equation y equal to ax square plus bc, in which we have put b equal to right now 0. So if I change a, then how the curves changes. And if I change the B, how this shifted, and if I change the C also, then how this parabola shifts. So all this we can visualize in this simulation. We can also see what are the poles, what are the vertex, and we can also see the different poles, different roots also. We can find the axis of symmetry also, and what are the roots of this equation. So these all, along with solving this equation, we can also visualize and how the different parameters they affect this nature of this curve. Okay, I'll just again replaying this. So if I changing this a, then how this curve changes, how the shape of this curve changes, and if I change this linear term, then how does it changes. And if I change the intercept, then how it shifts the parabola from an axis. Okay, so these all we can visualize. We can also calculate with the equation. Also, we can also see the vertex. What are the roots? Because we can visualize the roots are the points where the solution is 0. So these all we can visualize parallel to the calculation. So this is the beauty of this simulation. Now I'll just move ahead. So this till now we have seen one of the education resources, which is PhET simulation. And in PhET simulation, I have for this session I have just taken very just to starting point, just some of the simple simulations. But you can also work out with when you visit this website, this PhET simulation, you can find that some complex simulations are also available. The next simulation software or the open education resource which I just want to share with you is Geogebra mathematical application. And this Geogebra is very useful for the stuffs in which you require the equations. And some 3D equation to require, some calculation to require. So you can use this Geogebra. So what you have to do to use Geogebra, you can directly visit to this website, geogebra.org. And when you go to this website, you can directly click on Start Calculator. You don't require to download any software, and just Start Calculator, you start working on the Geogebra. And for the Geogebra, if you want to create an account, you can use your Google credentials. You can have an app also. There is in Google Play Store, even PhET also. One thing I just forget to tell you that with your mobile also you can have a PhET applications. So that app also you can download, and similarly in your Google Play Store you can find an application for Geogebra also. Okay, so you can download the Geogebra applications and you can start working on your mobile also. You don't require, it's not necessary that you should have a system to work on. And Geogebra, there are different software also available for the Geogebra. So if you don't want to work online, you can download the software and you can install it in your in your system also. Then you don't require the internet connection. But if you use its calculator, then you have to you require the all internet connection. And then there are resources available as in PhET also. Similarly in Geogebra, lots of the teachers, they've shared their resources which they've already developed, so you can use that resources. And just like your Google Classroom, you can also create a classroom for Geogebra application with your student, and they can submit their assignment and you can give the activity in the classroom also. So these are all the features available in the Geogebra. The PhET simulation is also you can share with your Google Classroom also. If you are using online platform, you can share your PhET with your Google Classroom also. So right now we talk about the Geogebra, that what type of figure we can work it out. So for this session, I've only taken the you can work in 2 dimension, you can work in 3 dimension, but just for the interest, because for the 3D diagram it's very difficult, to visualize. So for this session I've taken only for the 3D figure. So this is a figure of a curve x square plus y square minus 1. So how does it look like? You simply write this equation, and you can see this figure. Then another thing, you can see the equation of cone also. So z square equal to x square plus y square. You can see a plane also, which parallelly you can add a plane which can cut this figure. So you can visualize that also. Similarly, you can see the figure of a cylinder also. So this is an equation of circle, but in 3D this will become a cylinder. Okay, so x square plus y square equal to 9. So then you will get this figure. So visualization also you are getting. Okay, and parallelly there is a facility in the Geogebra apps that you can create an animation also. So there is a feature available which is known as slider. So suppose if you write an equation, so this is the equation of a sphere, right? X square plus y square plus z square equal to a. And in this, a is varying from -5 to +5. So how this sphere will change, or how the shape of the sphere will change when you change this a. So it will also give not a static visualization, but with this Geogebra you can create a dynamic visualization or an animation you can create. Okay, so with the help of this feature. So I've just this is not actually it's working on. I've just make the video of the actual simulation. So if you see that when the sphere is radius is from 0 to 5, so you can see that the size of the sphere is rising. So this type of animation you can create for your understanding, and you can understand that how this figure will look like, how this equation will look like. Parallelly, you can have a plane also which can cut. So at what point it will cut, that all you can show in this. So this is what all the Geogebra 3D calculator I just want to share with you. Okay. I request all the students and all the participants to maybe note down all these educational resources which can be helpful in their future learning. Okay. Now, one of the very much interesting app which Geogebra will provide you, and maybe the other app also. So I'll just discuss that also. Now the AR application. So nowadays, the things which in the previous simulation we are working in, we are working in a virtual environment. We are working in a computer screen, and in the computer screen, all those simulation are taking place. So nowadays there is a new concept or new technology which is augmented reality, and in short form it is known as AR. I'm again repeating it, augmented reality. Okay, augmented reality. And now if you are having a good smartphone, and in that if you download some AR apps, so that all those mobile, they will support those AR apps. So right now you are having an AR app or augmented reality app, and if you type a augmented reality solar system app, so if you download that app, then you will find that when you start that application, you will see you have to follow some of the steps. There is a grid, they require a surface, and when you click on the surface, then a complete solar system will be on your table, maybe on your floor, and you can see a sun in a virtual mode, okay, but in a real space. So that type of application, they are known as augmented reality application, and they are very good right nowadays. And we are, as an educationist now, the teachers, they are starting that why can't we use this augmented reality app for teaching learning process. So it will give us more real picturization or real visualization. So one of the AR app or the sample of this AR app has been given here. So I'm just starting this video. Please watch this video very carefully, and later on you can try it in your mobile phone also. So in this, this is a sphere. So this is just a sphere of GeoGebra, which we have seen in the previous slides. Now you can see there is a road, and a person is taking a balloon also, and with his hand. So what actually it is happening? This sphere is in real, in a real space. It is taking place, and again there is a sphere, there is a cone. And with this application, now this background is real, okay? In a real background, in a real space, this virtual thing will take place, okay? So this cone is there. This cone has been, maybe in your table, maybe on road, maybe on some gallery, you can form this, okay? And you can see this cone. So and later on you can see inside this cone also, okay? So this is the beauty of this augmented reality app. So this virtual figure has been there in your real space. I can again replay this video. So this sphere is in the real space, okay? But you have to see from your mobile screen, you have to see this, okay? And when you can measure some of the dimension of real object with this. Now there's lots of technological developments are there with the help of AR app. Real measurements, they are taking place with the help of AR apps. But now for concern for the teaching learning process, you can as a maths teacher or as a science teacher, you can use this application. As a student also, if you don't understand if you're not able to visualize some of the shapes, so you can make this, you have to write this equation, this application, and that figure will be in the real space, and you can look into it. You can from the top you can see, from the side you can see, and you can have more clear understanding of all those real figure with the help of this AR app. So please try to use this. So GeoGebra is there, and if you type in your Play Store some AR apps, so you will see the solar system app, and the other applications are also available. So this is the AR app just I want to share with you, okay? And besides this, there are a number of mobile applications that are available. So these are the some of the applications. One of my friend, Professor Loken Singh Chauhan, has given me the detail about detail of all these applications, and he is working on it. And I acknowledge him completely to give a consolidated list of all these applications. And there is a Vernier calipers app. So as class 12, we are doing experiment with the Vernier calipers. So what I suggest you do the experiment with the real application, with the real system also, and do with Vernier calipers also. So when we go with the two teaching methods, so definitely we will have more clarity, or we can, some more question will rise in our question, which makes our understanding more better. There is a smart tool. There is a smart tool application in which we can do speed measurements. We can do leveling. Okay, we can use our mobile for leveling also. We can use a mobile for a magnetic compass also, and we can design innovative experiments also with the help of this with the help of these mobile applications. Because we have an we are having an application which measures the intensity. So our mobile, they consist of lots of sensors. They consist of sensor in which we can measure the noise also. We can measure the intensity of the light also. So these experiments we can do on our own with the help of this application. There is an application oscilloscope with which our mobile phone will be converted into an oscilloscope. with the help with the help of those connectors which you use to listen the music. So this, with the help of same connector, with the help of those headphones, you can convert your mobile phone with an into an instrument. There is an FFT spectrum analyzer is also available. There is a spectrum, this BS spectrum is also available, with which we can measure the frequency meter, the sound meter, which I'm saying that you can measure the sound also. So you can measure the noise pollution of all around your area, and we can work out with some you can come out with some data also. And there is a complete application which is known as Lab for Physics, and this application with which we can measure the distance versus time graph, and all these experiments which in class 12 which we learn. So all those figure we can make with the help of this Lab for Physics application of mobile. So all the very best to all of you. I think you can use this mobile application to design your own experiments. And again, I'll come back to the to some websites which are useful for us. Okay. So sir, am I still audible? Okay, thank you very much for the feedback. So again, the government of India have taken lots of initiatives, and they have developed these experiments. So the previous in all the previous slides, that the simulation which I have discussed, all the ARF, Geogebra, and the PhD simulation, they are the contribution from the international educationists. Now, our government of India, they have worked a lot in this field, and right nowadays, in this virtual, when we are working in this online platform, so these websites, you can also explore these websites, and you can do your experiments. And lots of the school nowadays they are working on this simulation. So one of the website is olabs.edu.in, which is an initiative of the Amrita University. So one is olabs.edu.in, and another one is virtuallab.vlab.co.in, which is an initiative of IIT Mumbai. So these are the two websites which are very much useful. Please explore this website. You can find lots of your experiments related to physics, chemistry, biology, mathematics in this website, and you can start learning this experiment with the help of simulation. And these are also very interactive simulations. All the learning material is given, a simulator is given, and you have been given the what the activity you have to give. You have to perform in this simulator, and you can also do the measurement. So a feeling of a real experiment, okay, it's an alternative to a real experiment. Whatever the real experiment will give you, that it can't give you, but sitting at your home, you can also do this experiment. So this olab.co.in, and there are the do you not only on the maths, not only the physics and chemistry, you can do with the maths also some of the important theorems which or you will get an idea of how to make a real project with the help of this equation. Okay, so one of the thing which I have taken for the demonstration for this session is area of the circle. So when you go to area of the circle, you have to click on the scales, and when you click on the scale, there is a circle comes. So diameter of the circle is 2.94 centimeter. Then you can do, with the help of the simulator, you can divide this in equal parts, and then you can collect those equal parts. Okay, so there are 16 sections. Okay, and you can arrange those sections. You can arrange these 8 sections of the different colors, and then you can put one over the another, and of the blue and green color. And when you reconstruct this, so these will be changed, your circle will be changed into a a parallelogram, and you can find out the area of this parallelogram. Okay, and then you can find out the work, you can find out the value of the pi. So with this, I think there's a very common experiment which we do in our mathematics class to find out the value of pi by ourselves. Okay, so with this, I think one thing I missed it, with parallelogram you have to change into a rectangle. Okay, so you have to cut half of this triangle, and you have to put it here. Okay, so this will be a rectangle, and then this rectangle will be your with this rectangle you can have you can find the area, and then you can find out the value of the pi. Okay, So this is an activity which you can do in O labs. Okay. There's another website which is known as the vlab.co.in, and this vlab.co.in is a initiative of IIT Mumbai. There are lots of labs developed not only in the field of physics and chemistry, but also in the field of civil, biotechnology, chemical engineering, mechanical engineering, electrical engineering, computer science, and electronics communication. So if you're a student of an engineering also, you can visit this website. You can perform all these experiments in this virtual lab. Okay. And you have to sign in. You can use your Facebook, you can use your Twitter account, you can use your Gmail account, and you can start working on it. Okay. And whenever you go to this website, suppose if you type, you select electronics and communication. For electronic communication, you will find number of labs. So suppose, for example, I've taken the physical science lab. So in physical science lab, you are having number of websites, number of labs you are having. You are having this mechanics virtual lab, optics lab, electricity and magnetics lab, solid state physics lab, advanced analytical lab, molecular interaction lab. So number of labs are available. And if you are a student of a school or a chemistry student of science, of graduate student, you can use this experiment. So one of the experiment which I have just taken is a titration experiment, which is very common experiment. And I've just this is not an actual simulation, but a video of this. So you can change the speed of the titrant. You start the if you start the titration process, so drop by drop, this solution will go into this, and at a particular point, when this reaction will complete, the color of this will change from yellow to pink. So we have to just click this stop, and we can find out that how many volume of this titrant had been titrate has been. Okay, we have to just stop, because when this color has become pink. Okay, so I have to find a stop, and then I can find out that from this figure that how many volume of this has been used, and with which we can find out the normality of the solution. Okay, so when I use the same experiment in my lab, so there is a constraint that either the teacher or the availability of the resources, I will have at a time only one normality solution. But in this, you can change the normality of the titrate. Okay, you can change the volume of the titrate also. So there is a flexibility in simulation that we can do the more number of parameters we can change. So how maybe in simulation, maybe virtually we are able to see this, but we are able to see the effect. Okay, and we can change the indicator also, because in the lab we have only one indicator maybe at a time, because due to the time constraint also, whenever we perform the actual experiment, we can't do with the multiple variation in the parameters. We can't do due to the time constraint of the lab. We have only 2 hours or 1 hour in a lab. So at a time, at most, we can do 10 experiments in a complete, or 12 experiments in a complete session. So, but this in simulation, we can have one of the beauties that we can change the parameters, you can change the indicators. So more versatility in and how that phenomena depends upon the different number of parameters, that also we can visualize with the help of simulation. Okay, so this is a titration experiment with vlab.co.in. Now, this is, if you are interested to visit this, you can visit this website, which is PhET, free and open source software for education. And nowadays, in the previous slides, the things which we are working on it, they are all the simulation in which we have got the ready-made simulator we have got. So we have started experiment on it, we have started learning the concepts, but there are also some of the open source software that are available, with which you can design your own experiments. But as a student, I think you have to start working on it, and it will take time to understand how to learn this software. But besides this, if you explore these softwares, so there are some demonstration blocks are also available, which are readily available, and you can start learning on it. So if you're not interested in develop your own simulation, you can use the predefined simulations, or as time will pass on, if your understanding grows in the simulation, you can develop your own simulation. So in the coming slides, I'll discuss about one of the software, which is Scilab. Sorry, with which you can design your own simulation. So besides Scilab, there are number of simulations available, open source simulation available, one of which is common Python, eSIM, OSDEG, OpenForm, PLC, Modelica, Scilab Arduino, which has been hidden here. Okay, this is a symbol of Scilab Arduino. So Arduino is also a hardware, open source hardware is available. So you can use it for your project work. It's an open source hardware. Scilab is an open source software. You can make a combo of it. You can use Scilab. You can use Arduino with the help of Scilab, and you can do your project. So maybe in your project work also you can start using this open source software, because you don't have to purchase any license, and you can visit those website, and from there you can download this software. So in the coming slides, I just want to share some of the simulation simulation which you can design in the Scilab of your experiments. Okay. So if you want to download Scilab, you have to visit this website scilab.org, and there you can download this software. And this is a class 12th theory part, which is LCR circuit we are having. And in LCR circuit, we are having a inductor, we are having a capacitor, we are having a resistance, and they are connected in series. And I have to see that how this circuit will perform whenever I will change this, whenever I change this signal. Okay, so I see that. So I am also having this simulation. Okay, let's see if its results will come. Okay, so in this way I can simulate this. Okay, I can run the simulation and I can see the result also. So this is also a simulation which you can design. So real circuit you can design. So this is known as an XCOS model. So you can design a model of a real system. So in this XCOS, they are having a flexibility that you are having all this inductor, capacitor, and resistance. The blocks you are available. You have to just connect them. You have to drag them in this workbench. And then you have to connect it. You have to connect a voltmeter, you have to connect an ammeter, and you can see the response. Okay, so this type of model you can design in this Scilab. And the theory which you learn in your class 12th, maybe in your engineering, maybe in your graduation in your basic sciences, in physics, chemistry, maths, you can create a model. You can create a model not only for physics but also for a mathematical model you can create, and you can do the simulation. So one of the other examples which I have taken is an RC circuit. So this is a model for the RC circuit. So this is a capacitor, this is a resistance, and this is a DC power supply. And these are the two branches which are having two different time constant. And I have connected a voltmeter parallel to each capacitor. And this is an oscilloscope, and I have connected with this oscilloscope all the voltages of these two capacitors with this oscilloscope. And when I simulate this, so there will be, there's a charging discharging curve, how the capacitor charge. So the branch of the resistance capacitor which are having the low time constant, so it will charge more quickly. The branch of the RC network which is having more time constant, it will charge in more time. So we can visualize all these things when we do the actual experiment. When we do this actual experiment of RC network, so parallelly I have to take a track on the capacitor also, on the voltage of the capacitor also, and the time also. I have to that's why this experiment is very real experiment is very difficult. Parallelly I have to see the watch also, and I have to see the voltage also. So in a group I have to perform this experiment, and I can't perform this experiment with a very low time constant. So suppose if my time constant of my RC circuit is 100 millisecond or maybe 1 second. So in 1 second it will charge to 63%. So 1 second is very small time. So if I am having a real capacitor which is having a very low time constant, even in simulation I can do this study. Okay, because everything will come with it. And Similarly, one of the experiment, this is a simulation of one of the experiment in which we have to find out what is the energy stored in a capacitor, because once we know that whenever a charge passes or current passes through a capacitor, the charge stored in the capacitor. So if whenever in a RC circuit, the current is passing through this resistance, and I square RT is the energy dissipated in the resistance. The same amount of energy has been stored in the capacitor. So that experiment also in model I can do. I can find out the current, I can integrate that current, and I can multiply it with the square of I square RT with resistance, and I can integrate this and I can find out this energy also. So this type of simulation also we can do in RC network. Okay, and similarly the you have seen the experiment related to RC in your lab, but you don't have seen the experiment of LR with a DC circuit. The problem with this, not a problem, but the characteristic of this LR circuit is that the time constant is L by R. So if I increase the L, the resistance automatically increases. So it will decrease my time constant also. So that's why the time constant of the LR circuit is very less. It's in the milliseconds. So those experiments is very difficult, to design in a real experiment. So where we have a real experiment, to design very difficult to real experiment, we can go for simulation as an alternate also. So with the help of this simulation, we can see study the LR circuit also. Okay, and not only the electronics experiment we can design with the help of this Scilab, but also we can design some of the mechanical experiments. For example, the simple pendulum experiment. So this is all of you have seen the pendulum, but I think you have to but when you want to design the same pendulum experiment in the Scilab, you have to learn that how you can set this. So this is my gravity, this is my fixed end, and this is my pendulum, and in this this is my mass, and I have to use a position sensor. So whenever I start the simulation, so actually it don't vibrate, but in simulation it will change its position. So when it will change its position, I can measure its position and also the velocity also. So this is my real pendulum, and this is a simulation. When I start simulation, so it will from 0.1 again it will come to 0, it will go to negative 0.1 and some. So these are the change in the position of your real pendulum, and by measuring the time between the two same position, I can work out the time period of this pendulum. So how does it depends upon this gravity? How does it depends upon the length? How does it depends upon the mass of this? All this, because it is independent of the mass. So all this we can we can do this with the help of this simulation experiment. So not only the electronics experiment, we can simulate all the mechanics experiment also. Similarly, all of you have learned the projectile motions in your class 12th, class 11th. So this is one of the very good simulation which is available in Scilab XCOS. This is available in the demonstration. So here we can see the simulation. So this is all arrangement of my projectile motion. So this is projectile. Okay, and let's see that how it works when I start simulation. So what it will happen, it will when I start simulation, this particle will go and it will go down. Okay, so something like this. I will again replay this. So this is the output of it. Just wait a minute. In the projectile motion, so this is the projectile motion. Again, I am replaying this video. Okay. So this is the output. This show your path. Okay, of your projectile, and it depends upon the angle and all that how gravity and all that this path will depend. And you will see that there's in the book which we have studied, the path is parabolic, but in this there is a slight deviation from the parabola path, because in that we don't assume the air. Okay, so there is an drag from the air also, and due to that drag or due to that you can say that force, we have the path is not actually parabolic, it will just change a little bit. So that's why this is a real simulation. Okay, it's more to a real simulation. If you don't want any drag of air force, then you can also you can also simplify the simulation, and then you will get the real parabola whenever you run the simulation. So all the parameters you can see, you can vary the angle, you can vary the speed, initial speed, and you can find out that what is the maximum horizontal distance or what is the maximum vertical distance. All this you can work out experimentally, or in you can say whenever you perform this experiment, you can find those values, and you can also relate it with your calculated value. We can also do the thermal experiment also, not only mechanical, not only electrical. You can do the thermal conductivity experiment. So there are simulation models available where we are having two bodies, and we have connected with a thermal contact. So this is having some thermal conductivity. This body is hot, this body is cold. One is at 100 degrees centigrade, one is at 0 degrees centigrade. When you bring them in contact, these are the thermometers, and this thermometer will be displayed. The temperature across the thermometer will be displayed along this, and you can see that after a particular time, after 5 seconds, the temperature of these two bodies will be equal. So there will be no net exchange of the heat from one system to another system. So in this, when you change the thermal conductivity, I think this will come here, or maybe come to some other points. All these parameters you can change, and you can generate your own findings. Okay. Now these are all the X-force model. We can do thermal experiments, we can do mechanical experiment, we can do electronics experiment. Now the next interesting thing which I just want to share with you, because all in the previous sessions we had all the experiments we are doing in a virtual world. We in PhET we are doing in our system, in Geogebra we are doing in our system, in augmented reality. Okay, the virtual image is in our space, in a real space, but in Scilab also we are doing in a virtual space. There is one very good application which I just want to communicate with you with this session is a tracker software. So tracker software, please explore this software. This is available in open source physics. In open source physics, there are other softwares also available. One is tracker and one is EJS, which is easy Java modeling. And in this, which is software which gives you power that you can design your own innovative experiments with the use of your own mobile phone and with the help of this software. Okay. So these tracker tools, in which what we have to do, we have to take a video of a real phenomena. Suppose I'm dropping a stone, and or I'm dropping a ball, and one of my friend can capture that video. And that video and that event, it's very fast. The ball if I take a height of 1 meter or 2 meter, so that event will be take within 100 millisecond or maybe less than that. So if you want to find out that what are the different velocity, what at different position, at what time the ball are at different position, and what is the velocity of that point. So that video film will be a very good experiment for me to find out the gravity and to find out the conversion of kinetic energy to potential energy. So if you want to do that experiment, you can use the tracker software. Okay, so this tracker software, you have to create a particle model. What you have to do, you have to capture a video and you have to put your video in that software. So for example, I've taken from the people those who have developed the software. So in this, they have again taken a pendulum, and they are releasing this pendulum, and they are creating a video of it. Okay, so this is a pendulum which you and one of my suggestions is that please create a very short video, because if you create a very short video, then only it will be the transfer of the file is very easy. If you make a long video, then there are other problems. So please make a video of very few seconds or something like that. So this video, I think this video is very small. So you have only 1 or 2 oscillations. You can see that 1, 2, 3, or only three oscillation video is there. Okay. Now for this you have to take the background as dark, because whatever object you are taking, so that there should be a very good contrast between this. So this is the necessity of whenever you are you creating a video for such type of experiments. So and then you have to, in the real the video you are taking, you there should be some points where you should mark some standard measurement. Maybe suppose between this and these 2 points I have marked 2 points, and these are my standard length, suppose 1 meter or something like that. Okay, these 3 things are required. The video should be of very short time. There should be a contrast between the background and the object, and you should have some standard length measurement is there. Then what you do, you download this tracker software, and you download this tracker software, and in this in your system you upload your video. Then what you do with some with some arrangement, you sort out this point, and this tracker software, what it will do, it will track the position of these pendulum, this body at each instant of time. So this is the oscillating pendulum, and when it go from here, this place to this place, for each and every point, this will record the time and also the distance. Okay, so this X position is also there, so you can see that this X position, so at different how it is changing with time. So again, the pendulum experiment which we are doing, a very common pendulum experiment. So we have we have taken the data of it at different time, and now these are at different position, and you can also see that the amplitude is decreasing because their air friction is there. So due to this air friction, there will be a damping, and due to this damping, the amplitude is also decreasing. So that also, that feeling also we are, that in the real experiment which you do in lab, we don't have this feeling that amplitude is decreasing. But I think you can see that amplitude is now decreasing also. So there's a damping also. So you can have learned number of features, damping also, the time period also, because between these two maximum displacement we are having the time period. You can measure the time period, you can measure the gravity, you can do the gravity experiment also. And the one of the experiment which I suggested you, that you can drop a ball, you can drop a tennis ball or something, some other ball, and you can click that video, and you can upload that video in your tracker software, and you can find the time at different stand, because some of our trainees, they have done it, and they've also tried to find out the gravity with this. Okay, so this real experiment you can do with the help of tracker software. Let us summarize this session. So that's all from my side. Due to the time given to me, I think I'm already exceed the time limit. So let us summarize this session. In this session, we have discussed various open education resources such as PhET simulation, virtual lab, Geogebra, some mobile applications, and a tracker software, Scilab also, with which you can simulate the experiment. You can do the real experiments. What all you are doing. We are not saying that simulation will completely reject your lab, or this online education will completely replace your real learning. That's what we are not saying. We are saying that it will support your real learning. So if apart from your real experiment, please go on with simulation, because you can get some idea that how can I change my real experiments. So this will make your learning more better. Okay. So thank you very much for your patience listening. And due to this media, I'm not able to interact with the participant. So I hope that whatever I have said, it has been communicated to all of you. And references are there from the vlabs.co.in, scilab.org, PhET Colorado, and the other reference Geogebra also. And acknowledgement to the director NITTTR Bhopal, who has given me permission for this session. Curator and project coordinator Krishnendu Chaudhary sir from RSC Bhopal for invitation for the science day, and for me to be a part of the celebration. And one of my friend, very genius person, Loken Singh Chauhan from RIE Bhopal, for his suggestion for this presentation. Thank you very much.
Thank you so much, sir, for such an interactive talk and information that you have shared in your talk. I am quite sure the visiting audience, especially the teachers and students, will surely take advantage of the information of the resources that you have shared in the program. Now, may I once again request Chaudhary sir to please, for the vote of thanks to our speaker and also the visiting audience as well.
I'm extremely thankful to Professor Jeevakhan sir for covering a wonderful topic, because as science technology in a form of tool can definitely give us a better edge in understanding the concepts. So whatever simulation tools are available, that can definitely help to understand those things. And you have covered all the different variety of tools, starting from PhET to the Scilab. So means school students related tools to the engineering students related tools. So I think who are watching this video on our online platform, or the teachers or the students, they will really get benefited. And I'm hopeful with the help of this tool, they will clear out a lot of doubts, and they will, after clearing out their doubts, they will try to perform the experiment physically in their school labs, so that further clarity can be attained on the topic. So thank you very much, sir, from Regional Science Center Bhopal, and we hope in future also we'll have such kind of interactive talk, which is related to helping our viewers in understanding science to different technology. Thank you.
Thank you once again.
Thank you to Chaudhary sir, and thank you to today's speaker, Professor Hussain Jeevakhan sir, and thank you to all our viewers of the program who are watching us on our YouTube channel. So thank you very much. And one more important announcement for you all. In a very short, at 2:10 p.m. we will start a new show on our YouTube channel, that is Liquid Nitrogen Show, and which will be followed by the valedictory function of this week-long celebration program, in which the chief guest of the event will announce the winners of the contest organized during the week-long celebration. So thank you very much. Thank you to all of you, Professor Jeevakhan sir, thank you Chaudhary sir, and thank you to all our viewers of the program. Thank you very much.